G'day there, you're watching the Aussie BIM Guru, and today I've got a tutorial in Revit using the pyRevit add-in to purge unused view templates. So I'll be using Autodesk Revit 2020 today, Notepad++, pyRevit, and the IronPython programming language. All the versions are shown here in case you want to use the exact same versions as me, but this is a fairly evergreen tutorial for most versions of Revit and pyRevit. So I do recommend, if you haven't already learned a little bit about Python, do go over to my Python 101 playlist. It's a couple of hours long and it runs through all the fundamentals that I'll be sort of breezing through here. I also have a playlist for pyRevit where I'll be dealing with ways to set up the program, but also there'll be tutorials emerging over time like this one. And they probably will follow on from each other to some degree, whilst focusing on unique aspects of the pyRevit platform along the way. So I'll be showing both just basic setup and preparation of the tool. I'll be going through this fairly quickly, and from there we'll be jumping straight into Notepad++ to start writing our add-in, jumping over to the Revit API docs from time to time. I'll be dealing today with filtered element collectors. If you haven't seen them before, they're very useful. I'm just going to use a very basic one today. And then from there we'll look at some basic filtering of elements, in this case by using the in statement to check if an object is contained in another list of objects. I won't be using a great deal of what we call list comprehension or shorthand. I'll mostly be working in expanded format, but a lot of what I do could be done in more consolidated ways using list comprehension, if you know what that is. From there we'll be looking at using a basic select from list user interface and using a custom class in order to display a different property of an object, so using a key for a value, if you're familiar with that sort of technique in such engines as Datashapes. So let's jump straight in. If you ever find I'm talking a little bit too fast, feel free to change the settings or the speed of YouTube, and that might make me a little bit easier to understand. So we're just going to jump straight into Revit in this case, and what we're going to be trying to do is identifying any view templates in this model that are currently not in use, displaying them to the user and letting them delete any of them that they wish to check. Now this model by default isn't a great one because by default I believe none of its view templates are actually in use. So let's apply some of these templates. For example, let's apply our architectural plan, and let's also apply our site plan. And maybe let's also apply our elevation template. So now we should have some templates that are in use, which you can see up in the top right corner. So we can see there's 4 views, 2 views, 0, 0, 0, 0, 0, and 1. So we're going to identify programmatically using pyRevit which ones aren't in use and then display them to the user for deletion. So I'm just going to jump straight into a tool that I've pre-configured. So if you have seen my previous video on my channel, which in this case dealt with bulk revisioning, I've made a few changes to my setup. So in this case, I still have my folder that I'm pathing to in pyRevit under the settings. So this is my current toolbar structure. And from here, I'm just using folders with extension, tab, panel, and finally my tools here. And I do have a bundle in this file in the .yaml or YAML format, which is in this case just saying which order my tools appear in. Once I'm in the actual push button folder for my tool, I have another bundle file. In this case, it contains a title property, a tooltip, and an author. In this case, I'm not using any multi-line formatting. It's just a very basic bundle file. I also have a 96 by 96 pixel icon, which pyRevit knows how to display. And now I have a script, which in this case is anything followed by script.py, and pyRevit will run this Python script when I click on the button. Now currently the script is empty, so we do want to fix that. So in this case I'm just going to be starting off by actually bringing in some libraries from pyRevit that I need. So I'm going to be adding comments as I go, just for good practice. But in this case I'm firstly from pyRevit going to import both Revit, and in this case I'm going to also import .db, or the Revit database, and we're going to be using this every time we reference the Revit API to create a class object inside the Revit API itself. This is just pyRevit's way of knowing when we're referencing the Revit DB. I'm also going to import a couple of other common libraries that I use for scripts. In this case, I'm going to be importing forms, which we'll use for user interfaces, and script, which we'll be using to terminate the script at some points. So from here, we're just going to begin firstly by getting the Revit active document. Now you can reference, I believe, the variable doc by default, or revit.doc in pyRevit. I prefer to typically just store that to a variable called doc, because typically in programs like Dynamo or with Python, I'm usually working that way anyway. So I find it much easier to have my code written in a very similar way between those two programs. From here, we're now going to be collecting some elements. So we're going to be using what's called a filtered element collector. If you're not overly familiar with them, I do recommend having a look at the Revit API docs and also just browsing the internet generally. There's heaps of great resources out there. If you are looking for a very good one, it's my icon I just downloaded. I do recommend checking out this Learn Revit API website by Eric Fritz, which is currently under development, but there is a great booklet dealing with filtered element collectors. You can donate as little as £1 in order to access this fantastic document. Of course, if you're very good at reading, you can get a few free pages there. But if you are more familiar with Revit API docs, you're going to be looking for the filtered element collector class. In this case, we're going to be targeting the view class. So what we're going to be doing is creating a filtered element collector in the current document, and we're going to be using, in this case, an of class method in order to target the view class and also the view family type class. Finally, once we have them, we're going to be turning them to elements, so we can have a look at the elements themselves in further methods and statements in our script. So we're going to be looking at both view family types and views. So the reason we're doing this is because views can contain a view template, but likewise, view types can also contain a default template to be applied. So when we check if a template is in use, we need to look at more than just the views in our document. We also need to check our view family types at the same time. So in this case, we're going to be working with the view family type class, and we're going to be targeting, in this case, the default template ID property in order to find the ID of the view template that may be assigned to that view. And then we're also going to be dealing with the view class. And from that view, we're going to be getting its view template. So there should be a view template ID property. So again, noting this will be the element ID, not the actual element of the view template, but otherwise we're going to be targeting that. We're also going to be getting all the view templates by getting all views, which includes view templates, they fall under the view class, and taking any of them that do happen to be view templates first. So that's pretty much the basic method behind our script. Now let's actually put it into practice. So I'm going to begin, in this case, by getting all views and view family types, which I often just shorthand as VFTs. So I'm going to begin by getting all views, and I'm going to say in this case DB, because I'm creating a filtered element collector. So I'm telling pyRevit I'm creating an object. Now you don't have to use DB when you're dealing with properties and methods of objects that pyRevit already understands belong to the Revit API in how they're being accessed. But if you are creating an object, you will need to reference it with a DB dot. So from there, we can create a filtered element collector applied to the document, which we've already collected. And we're going to use the of class method. And in this case, we just pass in, again, the view class, but we're referencing this, in this case, with db dot. And then we're going to say where element is not element type. I don't believe this is necessary, but I do commonly use it anyway when collecting elements. So this will typically exclude things like if you're collecting all the walls in a model. If you don't specify where they're not element type, you'll also get wall types. I think with views it's not as problematic, but I'll do it anyway. I'm then also going to get all the view family types. So I'm just going to copy this line. It's a little bit easier. And this time we actually want to get them where it is an element type. So a view family type is an element type. But we're now targeting instead the view family type class. So with this, we should now have our views and our view family types. We can always check if this has worked. So if we want to say for v in views all, we can just print v to the console in pyRevit. And this should print out a long list of all the views and view objects. And we can see we have quite a lot of objects in this case. So all of these seem to have been successfully collected. Of course, we can also check our view family types. And we can also see that we should have our view family types collected as well. So we can now start to work with these using various filtering techniques. I'm going to, in this case, get a few things. So I'm going to get view templates, then used view templates by view and view family type. So in this case, I'm going to create some empty lists to store objects to. So I'm going to get all my view templates, all my unused templates, and all my used templates. And by default, these are going to be empty lists. So you can actually store multiple empty lists in one statement in Python, as long as you separate them on both sides of the equal sign using commas. It's a handy little technique. So I'm going to iterate through all the views in my model to check for these properties and also to isolate what I want to check the properties of. So I'm going to say for v in views all, if, and first I'm going to check, is it a view template? So I'm going to say in this case, if v is template, which will return true if it's a view template, I'm just going to use that to append that view, which in this case is a view template, and I'm going to append the ID because the other two properties we're using for these other objects will get a view template ID, not a view template object. And that's okay, we can work with that. So I'm going to get the ID property of that view template. If it's not a view template, then instead I'm going to firstly just check the view template ID. So I'm going to get the ID of that particular view, which in this case we know from before is the property view template ID. I'm then going to check if this template ID exists in the used templates already, because I only want to build a list with each of these once. If it's on 10 views, I only need to know that that thing exists once in my model. So I'm then going to say if that view template ID is not in templates used. So in is a really handy word. It just checks if an object that is exactly the same as another object occurs within a list. And if it's not, I'm going to go and append it to templates used. So this will only append the very first time that this object is found and doesn't exist in templates used. Very quick, very easy. From there, I can actually go and check, in this case, the same for probably the view family types as well. So I have to also say for view family type, in view family types all, and I'm going to be running pretty much the same logic. This time I know I'm not dealing with any view templates specifically. I can say if, and in this case, if, so again, I'm probably just going to use VT ID is equal to the default template ID, which we know is a different property of that view family type. So in this case, I'm going to be checking if that is not in. So again, I can really just borrow my code before. If it's not in templates used, then again, we're going to be appending that as well. So our list is going to keep growing with those view family types included also. Now I believe by default in this particular project, there isn't any view family types by default assigned. So I might just go and assign one to the architectural section so that we know this is also being used by a view family type. But at this point, we now have a list of used template IDs in our model. So from this, we can now check this against the actual list of view templates. So we can say in this case, and I might just maybe get a little bit more specific here, get view template IDs by view, and I might also say get them by view family type. So it's a really good habit to add comments as you go. I'm always going to do it in my tutorials, even if it takes just that little bit longer. Great habit to get into. So now we can say get unused view templates. And the way we're going to do that is we're going to go through each view template which we've collected. So for view template in templates all, and we're going to check if this occurs in the list of used templates that we've already got. So if the view template is not in templates used, then we know it must be unused. So from here, we can just borrow a bit of code. And we're just going to append this to templates unused. So at this point, we should have a list of templates not used. So I can just really quickly check this. For VT in templates unused, print, and I'll print the name just so I can see what it's called. I've probably made an error here in line 32. If view template is not in, oh, I don't need to say is, of course. It's too language correct. So we can see in this case, we should get a list, our element ID, of course. So we actually need to get the object to get its name here. So we're going to take the view template ID, which in this case is an ID. And instead, what we're going to do here, and I'll just make sure, yep. So we've got IDs, IDs, and IDs. We're going to say firstly that show element equals document, and we're going to use the get element method, which you pass an ID to, and it finds that corresponding element in the document. And from that, we can instead get the name of that object. This should now work. There we go, and we can see this is correct. These are all unused view templates, whereas all our used templates have been left out of this list. So I'm now comfortable that we can move forward with these objects. So at this point, we're going to want to firstly make sure that we have view templates to purge, otherwise we don't need to go forward. So I'm going to say check we have templates to purge. Otherwise there's nothing to show to the user. So I'm going to check the length of templates unused. And I'm going to check if it's equal to 0. Then we know in this case we're going to want to stop our script. So I'm going to go script.exit, but I'm also before that going to use a form. So if we go to pyRevit forms, I'll just close these. We can find in the pyRevit docs that we should be able to deal with what's called an alert. So in this case, an alert only actually needs a few things. It needs a message to show, a title to show, and we can optionally say whether we want it to have a warning icon, which by default is true. So we just want, in this case, a message and a title. Very easy. So from our forms library, we're going to create an alert. And in this case, our message is no templates to purge. And we can say the title is script cancelled. We shouldn't see anything right now because we do have templates to purge. So we can see that that is successfully finding templates to purge. So now that we have these templates, we're going to want to show them to the user. And again, we can use another form for this. In this case, this is going to be a select from list, which as you can guess is really just a list of objects that we select from. So in this case, we can deal with a few things here. Firstly, we have context, which is a list of objects to show. You can build this using a list or a dictionary. There's various types of inputs that are accepted. We're going to use a custom class in this case, and I'll show you why. But from there, you can do a title, a width and a height, and other various quargs or keyword arguments. So we are going to be using, in this case, a couple of keyword arguments. We're going to be using the button name to change it to purge, and we're also going to be using multi-select, which by default is set to false. We want to be able to select more than one view template, potentially. So what we're going to do here is create a custom class object, and I'll show you why. So let's just build up our user interface. UI to select templates to purge. And I'm going to use a trick as well in pyRevit, which lets you use multiple lines for one object. So what I'm going to do is I'm going to call this return options because we're effectively selecting what we want to purge. Now, usually you could start writing your select from list object, but I'm going to deal with this over multiple lines because it's going to get quite long. So when you want to do that in pyRevit, you can do this, I think that's the backslash, and you can just go to a new line, enter tab, and you can keep typing as if you're writing a single line of text. So I'm going to, in this case, use a select from list form, and I'm going to hit enter. And at that point, we can just keep writing as if we're on a single line. Now, in this case, I'm just going to, by default, probably show my templates unused and see what we get. So I'm going to use templates unused. I'm now going to say title is equal to select templates to purge. And then I'm now going to say the width, I'll just say is 500. I'm going to use the optional argument of button name so that I can change that to purge. And I'm going to set multi-select to true. Now I'll run this and we should hopefully get our UI. Exactly 5 keyword arguments. Interesting. Line 41. So I've missed something here. What have I missed? I need to show it. I believe that might be the problem. I'll just double check 5. Yeah, so now we can see a problem here, right? I don't know what those element IDs are. What element do they correlate to? Now we could take those elements, take those IDs, turn them into elements and get their name, but then we're targeting names in our user interface. So what we really need to form here is a key and value pair relationship with the object. So we want to tell the interface to show us one thing whilst passing through the element ID behind the scenes. So for now I'm going to cancel this and we're going to create a custom class in Python in order to achieve this. So back at the start of my script, I'm going to create a class. It's usually best to build classes and functions at the beginning of a script so they're easier to find. And I'm going to make a class to show a template by name. And we're going to be using a template list item class, which already exists in pyRevit as a wrapper base class. This is part of pyRevit, I believe. And we're going to build our own custom version of this class where we can define how the name of the property is set. But we can see more or less the shape of that class already being defined here. So in this case, I'm going to define a new class, and I'm going to call this template to purge. And I'm going to make this, again, that forms template list item type to begin with. And then I'm going to define a property of that class because we want to say what is the name to show in the user interface. So we're going to define that property of the object, which we always refer to as self in a class. Now I'm skipping a lot here because classes are really a lesson unto themselves. There's some really great tutorials out there on the internet, just generally in Python. I do recommend taking some, but really what I'm doing here is just telling this object to get the element from self, which we refer to as an item. So this at this point will say from the document, get the element ID. And then once we have that object, we can chain the name method onto the end, or the name property onto the end. So it's going to work its way through the brackets first, apply the method and get the property after. So from this, we can show the name of the object, but pass the element ID in the background. So we should now hopefully be able to just change this in our UI. So instead of taking templates unused, we're going to, in this case, make a different list of objects. So I'm going to use list comprehension in this case. So I'm going to say templates unused, and we're going to pass, in this case, a view template to it for VT in templates unused. So I've used a shorthand technique here just to turn all those templates into that class to put into the UI to show their name whilst passing the object in the background. And we should now hopefully, I've probably made an error and a phrase while passing. So I think I've probably made an error. Okay. Templates to purge. So I don't think I need to do that. I need to do that. I'm pretty sure. So we're going to do templates to purge for VT in templates unused. And we can now see that our UI is showing us the name of that view template, but in the background, it's still going to pass the element ID, which we can use to delete the objects that we select. So for now, I'm also going to create a check after this to say, have we actually selected anything in return options? So if we haven't, by default, pyRevit's going to see this as a none object or an object with no contents. In this case, we can use a simple if statement to make sure that this hasn't happened. So see if no templates chosen, and I can say if not return options, which means return options is none or doesn't exist, then we can just exit the script. And it's up to you whether you want to put a message or a warning there, because chances are the user has cancelled out of the script in this case, and probably as a result doesn't really need to see that anything's went wrong. So all that's going to do is give us the option to terminate our script at that point. But otherwise, we're going to keep going. So from here, assuming our script hasn't been finished, we're now going to try and delete all of our objects. So if template's chosen, try to delete. And with this, in this case, we're going to, and we could actually probably attach this on the back end of this statement actually. So I'm going to say if not return options, exit the script, else, and now we can try to actually run the portion of our script at this point. So we need to create a Revit transaction. So in pyRevit, in previous tutorials, you might have seen that we can use the with statement to create a disposable transaction object. I'm going to call this Purge templates so that when we're doing undos, we can see what's happened. And by default, we're going to count how many objects are successfully deleted. So I'm going to say count deleted equal to 0 by default. We're now going to say for each view template in return options, try to delete it. Now, I could write a full little deletion routine here, but I usually prefer to build a function in order to handle this process for me instead. I find it a little bit more efficient, a little bit easier to reuse this in other scripts, and eventually you might even build a custom library with this as a function. So I'm just going to put in here function to delete object. And in this case, we're going to define this as delete by ID, and we're going to take in an ID as the only argument. So in this case, I'm going to try to delete it. So if for some reason this object can't be deleted in a valid way, it should hopefully get caught in a try and accept statement. But it may not always. There are some conditions where the object may be checked out for ownership. In a future tutorial, I'll probably show you how to actually check if objects are available for editing and use a custom library to handle this as well. But for now, I'm just going to assume the only thing that could go wrong is it just can't be deleted in a basic try accept. So delete is a method that we apply to the document class, and we target, in this case, the element ID. So it's a pretty common one, this one, so I might actually just go to Revit API docs and find it. So if we go to the document class, we should find, in this case, a method. I believe it's somewhere in here. It might actually be delete method. There we go. So it should belong to, yeah, the document class. Strange. So in this case, we can delete using the element ID or a collection of element IDs. But in this case, I'm just going to go through them one at a time rather than try to delete them as a set of IDs. That way, if some can be deleted and others can't, we'll still get rid of the ones that we can delete. So in this case, I'm going to want to track that this has actually happened. So if it has, I'm going to actually create an outcome, which is 1. If it doesn't delete successfully, my outcome will be 0, and I can now use this to count the number of objects that have been deleted. So I'm going to return, in this scenario, 1. Otherwise, I'm going to return 0. So I can add this to my tally as an outcome of using this particular function. So it's a bit of a shortcut, but I do use this technique quite often. So now for each view template, I can take count deleted and raise it by the outcome of applying that function to the view template. So hopefully if it does delete successfully, my successful count of deletion will also go up by 1. At this point, I also want to track what's actually happened and say it to the user. So what I'm going to do is just build a final message. So I'm going to make, in this case, an outcome message for the user. And we're going to need to check a few things. We're firstly going to see how many objects we had in total to work with. So I'm going to call this my total count. And I'm going to make this the length of return options. So the total number of templates we tried to delete. And then I'm also going to make a count of the failed templates as well. I believe this should just be count total minus count deleted. Now I'm going to build up 3 scenarios. The first one is, in this case, that all templates were successfully purged. So if count failed is equal to 0, then I'm going to want to display just a message saying that all templates were deleted. So I'll turn, in this case, the count total to a string, followed by view templates deleted. Otherwise, in this case, I'm going to check that the number of items deleted was none. And in this case, I'm just going to say is count deleted equal to 0. And in this case, I can say no templates deleted successfully. And finally, we know that some were deleted successfully and some weren't. So in this case, this is just going to be an else outcome. It's the final possible outcome. And message will be equal to, first of all, the number of them successfully deleted, which we can say is view templates deleted. And then we can also say that some of them weren't. So we're going to say count failed view templates not deleted successfully. So we've created the conditional outcome to show to the user, finally just in a basic form alert like we used earlier on in our script. So I'm just going to go and borrow, in this case, my form alert from before. It's just easier. And then we can say final message to user. And in this case, we're going to show message, which will sometimes be different depending on the outcome. And instead of being cancelled, the script is now completed. We're also not going to want to show the warning icon. So back in my pyRevit class, so if I go to my forms.alert, whoops, I can see in this case I have an argument for the warning icon somewhere in here. Let's go back up to the top. I thought there was a warning icon argument in here. Yeah, there we go. It's just not listed. So in this case, we don't want to show a warning icon. So we want this to be false. And we should now have a successful routine for showing a list of view templates to the user, showing them as the name, passing the ID in the background, taking all successful view templates that we selected from the list and trying to delete them, then reporting the outcome back to the user. So let's try running this. We should see a list of those templates. Let's just try deleting maybe 2 of them, purge, and we can see 2 view templates have been deleted. And let's try doing all of them. So we should now have 3, which we do. Purge them. And now that there's no templates left to purge, we should instead see our first catch, which is there are no 2 templates to purge. So there we go, a pretty handy little tool. It's taught us about filtering of objects, collecting objects, and also some interesting techniques such as using a function, a tally tracker out of the function, and also a custom class to display a different object for a user interface based item. So a fairly extensive tutorial. We've covered quite a lot of ground, but hopefully it made a good deal of sense. And if not, again, I do recommend you check out my Python tutorials if some of the basic fundamentals didn't make sense there. You can find all the content, including today's scripting forays, over on my GitHub. And I hope you found this tutorial interesting and you're enjoying learning more about Python and pyRevit. So if you do have any questions, feel free to email or drop a comment below, or if you have a request, then I'll do my best to take it on board. So thank you for watching today, and I look forward to seeing you in future similar videos. Thanks. Take care. Bye.